A and B. So let's pretend my A is the side that I open. Okay, this point is A. So I put a dot where my A is. So that's my point A. All right. Now I open it, and it becomes that. So this is AA. Initially, this part is just L, the slant length. Some call it slant height. This slant height is definitely the radius of the sector when I open it. That's what they are saying. Okay? So we can label this as L. Understand? So what else can anybody tell us? Thank you, Yanko, for that. Raise your hand if you have another one. Not Dennis. Joey.
The circumference of the circular base of the cone.
The circumference of the circular base of the cone, yes?
Equals to the arc length of the sector.
Do you agree with that?
Yes.
This is the base of the cone. The base of my cone is a circle. Right? So the circumference is the distance around the circle. We've talked about that quite long ago. When we open it, it's actually the length of arc of this sector. So, with this as R, the circumference is 2 pi R, then definitely AA is 2 pi R, not analysis and approaches. Point AA. Melody, not analysis and approaches math. AA means point AA. Okay, thank you. Does that make sense? So just so you to see this. Now, in question 9, we have question like this. You need to be able to say it exactly the way those two people said it. The circumference of the base of the cone is the length of arc of the sector. So when you're writing your formula on left hand and right side, you need to write the appropriate formula. You need to substitute the appropriate number. Otherwise, you won't be able to solve number 9. Are you with me? Similarly, the slant height here is the radius here. Okay? Actually, this idea can be used to prove these two formula as well. But there's no need to do that. Now, go to question 9, everybody. Everybody go to question 9. Last page. And you see that? So for question 9, you have a sector. Okay, a cone is made from that sector. Find the slant length S. That slant length S in the cone is equivalent to what in the sector? R. So which means if you can find R, then you find your L, right? But you don't need to find it that way. Actually, from the original shape, you can find your slant length S from the cone itself. How? Raise your hand. How can you do that? Raise your hand. I'm waiting for more people. Looking at the cone alone, we can find the slant length S. Anika. Say that again? I don't think so. Look at it very well. Ryan? No idea? King? Come on. Anika, want to try again? Pythagoras theorem. That's a right angle triangle there. Because that's a right cone. Even though I should have put it there that cone is the right cone. Do you know what the right cone is? What is the right cone?
The thing is at the
center of the base. We talked about that in the 3D, right?
Yeah.
Aha. A right cone is the one where the vertex is exactly at the center of the base when you draw the perpendicular height. So if that is the case, that is automatically angle 90. And if you have angle 90, that's your right angle triangle right there. Where S is the hypotenuse. Is that not?
Yes.
And that's how you get that. And to get your R, what do you do to get your R? R is equals to S. You just, you know, R is equal to S, which is equal to whatever answer you have gotten already. That's it. And then you find the length of arc of the sector, then you find the angle. All right? So now you can do that. And once you are done with question 9, look at the board, please. Once you are done with question 9, I want you to attempt this on your own later. This is the question 1 of SL paper this year. Paper 1, question 1 this year. So it's a similar idea. Okay?
What's 100 by 136? Choose 12 point something. No, 11 point something. Okay. Fine, I'll do it. I got it. Get off. Oh, what?
Just leave it. It's okay.
Oh, choose that to before.
This is, it says here, suppose here. And this is a radians. Yeah, I know how you use it. Yeah, but some game will do functions. Don't show the body. Titanium square, A square plus B square plus C square.
Alex, I like your eraser one. Use this one. Theta is theta.
Yeah, it's just,
No. We need to find the length of arc. The length of arc, we use the circumference of the base of the cone.
yes.
You get me, bro?
Yes.
You get me, bro?
I gave you one.
I also bought 6 more, but I lost it again. No, I lost one, and I haven't bothered grabbing it. So
They're not gonna see.
yeah, it's just £2.
What's the answer?
Give me 1 second. I haven't gone to
Yes, ma'am. Of course.
37.7 cm. Did you get that?
37.
Yes.
36.
No, 37, bro. It's 37, mate.
Why?
Because I said so. It's 37.
What did you get? Give me.
36.6.
No, give me 9.
36.6.
Give me 9 paper.
I got 36.6. This one is
What idiocy. Oh, right, yes. You're right. You're right. Wait, what? Oh, dude, Elsa. Mate, you use the slant length. You use this. You use the slant length. It's not the slant length. You need the radius, mate. Well, where do you get the slant length from, mate? Stupid boy. Center angle. Wait. Yeah.
I've seen this question.
Finish this one already?
They just
Give me this.
no. Do it yourself.
Alright.
Guys, I put some notes. Please, everyone, I put some notes here, but I don't have enough space to write. So the continuation of the notes is here.
Okay.
Okay, thank you.
Listen, you find this S, right? But you have 6 here. You have 10.
I do the last one. I don't want to bother.
You're not even in the right setting.
I will totally use the last one.
In degree, find the circumference of the base circle.
Ryan, any problem?
Not the entire circle.
Yes.
I think you just take Kelly's piece.
What?
I think you just
Yeah.
take Kelly's piece.
This is wrong. This
Yeah, I did. And of course, you try question 10 on your own.
等一下，我在试试 follow me please.
Segment is not part of your syllabus. But maybe I can put a short note about segment.
Area is equal to 2. Wait, oh, it's perimeter, right? What formula is this? Length is equal to pi r. Oh, you're genius.
Get 80 right.
What's the answer?
I was saying do some work and stop doing that. Have you finished? Then put it in your notes and do it.
It's a radian. I'm not going to use.
Take some time, right?
Pretty sure it's
don't
already-
do it immediately. Not trying to think about
Because everything
it
we've
now.
done is because you put degree, so it was rad, bro. Rad.
This is
I don't know how I got
No.
into it.
Rad.
Right? No.
Pretty sure it's rad.
No square.
You have PEs, so I'm going to let you go in 3 minutes.
Wait. 呢個係一定係90度㗎啦，呢個
because it
Let's find the area first. That's like we need the area of triangle. Perimeter. We don't need any area.
Guys, can I have your attention for 3 minutes? Joey, do we have this part?
Yes, we do.
Thanks. Everybody please pay attention. Even though segment is not in your syllabus, last time I checked, and I haven't seen a question that asks for segment, the idea could be useful in some questions. So which is why I want you to listen to this. Okay? Just like I define sector, I define segment as a region bounded by a chord and an arc. A region bounded by a chord and an arc. So when you have a circle and you can draw a straight line, you have just divided it into 2 segments. Okay? So this is a major segment, this is a minor segment. Some of you will remember alternate segment theorem in IGCSE. We talked about segment then. It's a region bounded by a chord and an arc. A chord is any straight line you draw from one end of the circumference to another. Diameter is the longest chord in the circle. because it passes through the center. Every other line is also a chord, as long as it goes from one end to another. Okay? This is why I always say that a semicircle is a sector and also a segment at the same time. Because a semicircle follows the definition of a sector. It is bounded by two radii, which is a chord, and an arc. The arc is neither minor or major. Does that make sense? A semicircle is also bounded by the longest chord and another arc. So it's also a segment. Now, this is a major segment, it's a minor segment. Sometimes, area of a segment is required, but I don't think you need to. The AI question that came out this year has to do with length of arc and I think area of the segment in the AI question. So maybe it is in their own syllabus. If that is the case, one will expect them to do this. Okay? Now remember, the segment you are looking for is here. Okay? This particular segment will also subtend an angle theta at the center, degree or radian, nobody cares. So if you want to find the area of the segment, what would you do? Alex?
The area of the sector, and you minus area of the triangle.
You find the area of the sector, then you minus the area of the triangle. Area of the sector is already known, half r squared theta. Area of the triangle is half what?
BH. Base the side.
Area of sector is half r squared theta is on the board. What is the area of triangle? Anyone wants to tell me something I want to hear? Say that again. R squared sine theta. What do you mean BH? We're talking about this particular type. Understand? Area of this triangle is half product of the two sides. The two sides are RR. And the sine of angle between them. Nobody told you anything about base and height. You don't know any height. That's the reason you learn these different areas of a triangle. Because of situations like this. Okay? So which means, if I want to find the area of a segment, so area of segment is equal to area of sector minus area of triangle, right? Area of a sector is half r squared theta. Area of a triangle is half r squared sine theta.
Yeah.
Does that make sense?
Yeah.
From half AB sine theta. A and B are RR in this case.
Yeah.
Hello?
Yes.
So we can now say that our area is just half r squared. In the bracket, what do we have? Speak louder, please. Theta minus, and that will be the area of segment in radian measure. Again, segment is not in your syllabus. But what if it is linked to a particular question? Or somehow it's related to this idea. You need to be able to reason like this. Okay? Thank you very much. I'll see you tomorrow.